Sorry, my paper might be a little red.
You better apologize.
No, sorry.
All right. Daniel, we only have 20
Coda, I'd let you up.
This jokester. What? Wonderful. I printed extra just for people like you. No, we're not doing that. We're doing a lot of math because we're getting up to the semester, guys. Midterms is Friday.
I think our midterm should be Candyland, and whoever wins gets like just.
It's a great idea. I'm going to help you. You don't have it? Okay, that's right. I knew I needed to give it to somebody else. I just couldn't remember who it was. Anybody else need one of these? How about you?
Well, I got Coda and
No?
I have
Are you sure? Good. All right. That slap on the back of the head, that was preemptive. I knew I'd need to do it, so I did it ahead of time. It was for future reference. Waste of money. God. I hate all of you. Yeah, okay. So, look at number 3. It says we're going to flip the point across that line. Excellent. Look at number 4. Let's do this one. This one's more interesting. So, our point is 2, 1. And we might have done this last time, correct? We did not do number 4. We did number 3? Yes. Wonderful. All right, so we're on number 4. Those of you following along at home. Here's the deal.
Who watches that movie?
Some people do.
Oh, they do?
Apparently your parents do. They're like, hey, you're funny. It's like, oh, God. Yikes, how am I not fired? All right, so 2, 1 is the point. We're going to reflect it over this line. So how do we graph that line? Well, it's in slope-intercept form because the slope is there and there's the y-intercept. So I'm going to graph it by plotting the y-intercept at -2. And then using our slope to find another point. What's the slope?
What did Jenny have to say about you?
Down 2/3. Jenny had great things to say. Shout out to Mrs. Anderson. All right. So that's the line of reflection. Now, we know how reflections work, right? If I am looking in the mirror, yeah. All right? As I move closer to the mirror me moves closer. Dear God, right? But as I move further back, so does mirror me. Meaning that the distance between myself and the mirror on this side is the same distance as the mirror to mirror me on this other side, right? So, the distance between this dot and this dot will be the same between this dot and the dot that gets flipped over the line. So we know the distance is going to be the same here and here. In other words, that's going to be a midpoint between the two, right? This point right here. Now, where is that point going to end up? Well, it's going to end up on a line that goes through this point and this point. That line will be perpendicular to this blue line. Cool? All right. So, let's find the line that's perpendicular to the blue line. Well, we know that a line that's perpendicular to the blue line will have perpendicular slope. Remember, perpendicular slope is when you flip it and change the sign? So our perpendicular line is going to be y equals 3/2 x plus b. Alex, I would highly encourage you to not do that because that hasn't worked out so well, right? But you make the call, man. Shout out to Jenny. All right, so.
I've lost my water bottle.
Well, technically you didn't lose it because you still know where it is.
Awesome. All right, so what we're going to do is we're going to plug in this point to figure out what b has to be. The idea being that whatever this line is, it has to go through 2, 1, right? It has to go through this point right here. So that means if it goes through that point, when you plug in 2 to its equation for x, 1 should pop out for y. That's what it means if the line goes through that point, right? That point is on the line. No yawning in math class. Meaning that 2, 1 should pop out. So we have to figure out what b has to be for 2 to get us 1. In other words, when we plug in 1 for y, and 2 for x, what does b have to be to make that happen? What does the y-intercept have to be, right? So we do math. What's 2 divided by 2? 2 divided by 2 is 1 times the top now. 3. So 3 halves of 2 is 3. Again, you could have done top first. 3 times 2 is 6. Then divide by 2 and get 3. Or you could have divided first. I divided first because dividing makes numbers smaller, and I like smaller numbers. Subtract 3, I get negative 2 is b. So that means that our line, our perpendicular line, is going to be y equals 3 halves x minus 2. Okay? So this line right here is the line that goes through this point and hits this at 90 degrees. So our reflected point, when we flip it, is going to be somewhere on that red line. Here's the red line, y-intercept at negative 2. That's convenient. Up 3 over 2 gets us the other point. Ha! Of course it does. So here's our line. So our reflected point is going to be somewhere on this red line. And the better you draw it, which I did not, the more accurate that will be. Now, where is it going to be on that red line? Well, it's going to be the same distance between here and here and here and here. So I'm going to eyeball this. Looks like it's up 3 over 2 this direction, so down 3 over 2 that direction is probably where it's going to end up. So it's going to be like here. That's going to be our reflected point. Here's our original point A. Here's our reflected point A prime. Now, we want to know exactly where that is, not just eyeball it. Because sometimes our lines aren't going to be clear-cut like mine is, even though mine is drawn pretty poorly. So what we're going to do is we're going to find out what that midpoint is. We already know that A was given to us. It's 2, 1, right? If we find out what the midpoint is, we can use midpoint formula to find out what A prime is. So how do I figure out what this point is right here, the intersection of the two lines? Well, one, I could just look at it. It's 0, negative 2. But sometimes that's not going to be accurate, right? It's going to look like it, but maybe it isn't. We need to know for sure. Other times, I'm not going to give you a graph, and I'm just going to have you do it algebraically. Yep. So, algebra hard, geometry easy.
No, I do not agree.
Yeah, we don't agree.
So, geometry is just looking at it, right? It is what it is, geometrically, visually. We're going to figure it out algebraically. So, how do we figure out where two lines intersect?
You look at the point.
Yeah, you look at the point, but how do you figure out where two equations intersect if you aren't given the lines?
Slope and y-intercept.
Nope. Well, in this case, it will be because they have the same y-intercept, so they will intersect the same spot. Here's what you do. We'll do it up here. Should be fine, right? Nope, you guys can't see green on there, so we'll do it down here. All right.
Then you do black.
Here's what you're gonna do. What?
When did you subtract like 2 and 3, basically to find?
Something like that, but we're not gonna use the graph. We're gonna do it algebraically. You could do it visually, but if you're gonna do it visually, you can just look where it is, right?
Yeah.
Right. But if you do it algebraically, here's what you got to do. So our original equation was y equals negative 2/3 x minus 2, right? That was this guy. And then we found the perpendicular equation to be y equals 3/2 x minus 2. Well, if y equals this and y equals that, don't these two things equal each other? Substitution, right? So I know that negative 2/3 x minus 2 should equal, that was fun, 3/2 x, whoops, we want red,
Christmas colors.
minus 2. That's right.
What about things?
So, we're going to find out where these two lines intersect. In other words, where they agree, where they equal each other. That's what an intersection is. So now we solve. Well, if I add 2 to this side, that goes away. And we get negative 2/3 x equals 3/2 x. I'm going to add 2/3 to this side. So I get 0 equals 2/3 x plus 3/2 x. Well, now we need to get common denominators. So 2/3 is the same thing as something with a 6 on the bottom. 4/6, right? And 3/2 is the same thing as with the 6 on the bottom. 2 times 3 is how we got there. So what's 3 times 3? Is 9/6 the same thing as 3/2? Are those two the same? Yeah, right? It's just a different way of looking at it. And the reason we want to look at it that way is because now we can combine them, right? We didn't change the problem. We just got a different perspective. Over 6, 4 and 9 makes 13. It's supposed to be what? It actually won't matter, and I'll show you why later. But yeah. So check it out. 13 over 6. We're going to multiply by 6 divided by 13. Zero's over there. In other words, think 13 over 6 times what gets us 0? 0, right? X is 0. Could you have done more algebra to figure that out? Sure. In fact, you could have stopped once you got to here.
Yeah, you see.
Something times x plus something times x gets you 0. Well, they both have to be 0. If there was a minus sign there, that could change, right? But it's 0. X has to be 0. So where they intersect is at 0 comma something. Well, what I'm going to do is I'm going to take that 0 and I'm going to plug it into one of these equations and find out where they intersect. Well, if I plug it in here, what's 3/2 times 0?
0.
0. Subtract 2. So y is -2.
I think we learned that last year.
Ta-da! That's where they intersect, which is what we saw visually, right? So to find out where two lines intersect, you just set them equal, right? Maybe.
Wow.
So the midpoint
That is cold.
is at 0, -2. And we know A was given to us as 2, 1. We need to find A prime, AMA. No yawning in math class.
How can't you? That's the thing. Ooh,
You're right.
factual.
So here's the deal. We know the midpoint, we know A. We need to find out where A prime is. We know that that's the midpoint, right? So we can use midpoint formula to find the other guy. Smell what I'm stepping in? What is midpoint formula, children?
Half x, half y, something like that.
How did I make you say it?
Over 2, yeah, y2 plus y1 over 2
X, what is X1?
I could get the paper off, I really don't want to. Something over
I'm
2.
hearing minuses. I'm hearing slope formula.
Something over 2.
I'm hearing all kinds of garbage.
Something over
Guys,
2.
it's the average point, the midpoint. How do we average things?
Something over
Add them, not subtract them, and divide by the number of pieces. And there's 2 of them, right? So we're going to divide by 2. How many pieces do we have? We have 2, and we're going to add them together. Average of the x's, average of the y's. You dinguses. Say it with me. The average of the x's. Okay, yeah, that didn't work. All right, let's try this again. Say it after me. The average of the x's. The average of the y's. I am a moron,
I'm smart.
but I can change.
I can't change.
All right.
But you cannot change.
All right, so we know the midpoint. It's 0, -2. So that goes here.
What'd you call us today?
Nimrods.
Nimrod.
And we know one of the endpoints, 2, 1.
You remind me of a Nimrod. I don't even know what a Nimrod is, but I know it's you. 1.
2, 1 was A. 0, -2 is the midpoint. Remember this from a quiz a while ago?
No.
All right, so this bit right here should equal 0.
C.
So how do we solve this? Well, we're going to do it in our heads. So buckle up. No writing. Look up here. How do we get rid of divide by 2? Multiply by 2. What's 0 times 2?
0.
0. So we have 0 equals x plus 2 now. How do I get rid of a plus 2?
0.
Minus 2. What's 0 minus 2? -2. So x is -2. Over here now. Get rid of the divides by 2. We times by 2. What do I have here now? -4. Now subtract 1. -5. I'll show you that again in slow-mo. To get rid of the divide by 2, I multiplied by 2. It's now -4. Then I subtracted 1. It's now -5.
That's not very slow.
Alex, what we did? what we said was we are going to multiply by 2 to get rid of this divided by 2, right? So that's now negative 4 because I multiplied by 2. Then I subtracted 1 to get y on its own, negative 5. Okay, we could have written it out. So negative 2, negative 5 is where a prime should be. Is it? Negative 2, negative... yeah, it is. That's good. So a prime, is negative 2, negative 5.
Shout out to
Mr. Lavelle.
He's a man. Negative.
So that's a prime.
Yeah.
Why am I making you do it this way when we had it right there? Because eventually I'm not going to give you the graph. I'm just going to say find where the reflected point ends up, right? And you need to do the stuff. Here is what we did. It seems like a lot, but it's not a lot if you break it down into concepts. If you break it down to steps, good God, right? Steps are dumb. Okay? Here's what we did. We graphed the original line. We know how to do that, right? There it is. Then we plotted the point. There it is. We can do that. That's not hard. Then we found the line that's perpendicular and goes through that point. Perpendicular slope, flip and negate, right? Plug in your point. There was the line. We graphed that line. Then we figured out where they intersect. How did we do that? We set them equal to each other. We found where they intersected. Then we took that point and used it in midpoint formula to find a prime. We plugged it in. Again in slow-mo. We graphed the original line. We plotted the original point. We found the perpendicular line and graphed it. We found where they intersected by setting them equal. And then we took that point and plugged it in the midpoint formula. The idea is that the point, when it's reflected, is going to be on the perpendicular line, and it's going to be the same distance on both sides. So find the perpendicular, use midpoint. How do you feel? Better? Let's do another. Skip number 5. Good God. Skip number 5. Let's do this. Directions are different this time. It says use the midpoint formula to find the line of reflection that takes the preimage to the image. So here's the preimage. Here's the image, where it ends up. Okay? We know we're going from here to here because we go towards the primes, right? So remember that the line of reflection is always going to be on perpendicular and on the midpoint, right? So what we're going to do is this. We're going to find the midpoint between these lines, or between these points. So here's A and A prime. And here's C and C prime. Let's do B. B and B prime. All right, we're going to find the midpoint on those lines. And those two midpoints, if we connect them, are going to make our line of reflection. So we're doing it in reverse. Before they gave us the line, and we reflected it, right? Now they're saying I already reflected it. Figure out what I flipped it over, right? What was the line that I flipped it over? Well, the line we flipped it over is going to have both of these midpoints on it. So let's find the midpoint between these guys. A has a set of coordinates. A prime has a set of coordinates. We're going to find the midpoint between them. What's A's coordinates?
A's coordinates?
Yep. Negative 4, 6, too slow.
1, 2,
What's A prime's coordinates?
4, 5,
6, negative 4, too slow.
1, 2, 3, 4. Is actually negative 4, 6. Oh, you did it.
What are B's coordinates? Negative 8, 4, too slow.
1, 2,
What's B prime's coordinates?
4,
4, negative 8.
4.
Interesting. All right, so we need to find the midpoint between these two guys, right?
Interesting.
So let's find A's midpoint. What is midpoint formula? Good, so we're going to add them together and divide by 2, right? Here's what I'm going to do. I'm going to write x2 plus x1 over 2. That's the formula. y2 plus y1 over 2. Let's do this in our heads, though. So we're going to add the x's together and divide by 2. What's 6 plus negative 4? 2, right? 6 minus 4? It's 2. Divide by 2. 1. So the midpoint is going to be 1. What's 6 minus 4? Divide by 2. So I just did midpoint formula in my head. The midpoint is 1, 1. Ah. There it is. Now let's find B's midpoint. Negative 8 plus 4. Negative 4. Now divide by 2. Negative 2. So the midpoint for this is going to be negative 2 for the x. Now let's do the y. 4 plus minus 8 is the same thing as 4 minus 8. What's 4 minus 8? Negative 4 divided by 2. Negative 2. So there's the midpoint for the b's. Our line is going to be where those 2 points intersect. So this is the line of reflection. All right, we've got these 2 points. What's the slope between these 2 points? Because we need to know the equation, right? We need the slope. Well, it looks like we go up 1, 2, 3, and over 3, right? Don't we go up 3 over 3 to get there? So what's our slope? 3 over 3, which is 1. So 1x. What's our y-intercept? Well, it looks like 0, but how can we be sure? Use your slope. Starting here, if I go up 1 over 1, and I go up 1 over 1 again, don't I end up on 0? Okay, so that checks out. It wasn't just it looked like it went through 0, it actually did. Up 1 over 1, up 1 over 1. Yeah, I'm at 0. So there it is. That's the line of reflection. One shot, one kill.
Try this, right? Put it on your head, bounce it.
No, I'm good.
One, try,
All right, give it to me.
try your practice.
All right. Best not miss. All right, so next 2 points. Before, we were able to find the line of reflection pretty easily, right? Find the 2 midpoints, connect them, figure out the equation. What's going to be the problem for this one?
That was a dome cutter if it did in my bottle.
We're only going to have 1 midpoint, right?
If I move the bottle.
Yikes. All right, well, let's find the midpoint. It's going to be somewhere on this line, right? A going to A prime. We're going to write down the coordinates and find the midpoint. Looks like A is 1, 2, 3, 4, 5, 0. And A prime is negative 1, 2, 3, 4, up 1, 2, 3, 4, 5. Negative 4, 5.
Oh, I miscounted.
Yes, you did. Let's find the midpoint. In our heads, average of the x's, average of the y's. We're going to add these 2 together, and then we're going to divide by 2. What's 5 plus negative 4? 1. Divide by 2. Half. Un half. 0 plus 5. Divide by 2.
2.5.
5 halves.
Over 2.5.
Or 2.5, but decimals are dumb. 5 halves is way easier to work with, trust me.
Are you sure?
So, a half. Up 5 halves. Let's count 5 halves. 1 half, 2 halves, 3 halves, 4 halves, 5 halves.
Right about there.
And here's the problem. We don't have another midpoint to make a line with. But we know that this pink line right here is always going to be perpendicular to our line of reflection, right? What's the slope of the pink line? What's the equation of the pink line? Here, I'll write it like this. What's the slope of our pink line? How can we figure that out? What's the slope of our pink line? How do we figure it out?
Count.
All right, Daniel, how do we do it?
Start on A.
All right. We're going up 1, 2, 3, 4, 5. So we went up 5, right? And we're going left 1, 2, 3, 4, 5, 6, 7, 8, 9. So our slope is negative 5/9. If we want a line that's perpendicular to that, what is its slope going to be? 9 over 5. Positive or negative? Positive or negative? Positive, because we changed the sign. Flip it and change the sign, right? Cool. So you know our line's going to be this. Cool. We want the equation, so we need the y-intercept, right? So here's what we're going to do. I'm going to take my slope. I'm going to go up 9/5. So when I do that, you know what? Let's not do that. I was thinking we could go up 9/5, but I think that might confuse you guys. What would be a better way to do this?
Flip 9/5.
Yeah, I think we're just going to do that. We're going to go up 9/5. So check it out. We're in the middle, right? So when we go up 1, we're still in the middle. Are you smelling what I'm stepping in? Eyes up here. Midpoint's in the middle because it's at a half, 5 halves, right? So when I go up 1, I'm still in the middle. Go up 2, go up 3, 4, 5, 6, 7, 8, 9, and over 5. 1, 2, 3, 4, 5. So now I have my 2 points. And this is going to be my line. That's the line of reflection. We need the equation. How do I figure out what B is? What am I going to plug into y and x? I need to plug something in, right? Plug in what? Yeah. So this point right here is the midpoint. Isn't the midpoint on the blue line? That means if I plug in a half to the blue line's equation, I should get 5 halves for y. And then we can figure out what b has to be. So 5 halves should equal 9/5 times a half plus b. Cool?
Cool.
So now we're here. We multiply across, right? 9 times 1, 5 times 2. 9 times 1, 5 times 2 in the bottom, because multiplication is just division, or division is just multiplication done on the bottom. And now we subtract 9/10. So we have 5 halves minus 9/10. We're going to need some common denominators. So that 2 right there, I need to make it a 10. Multiply by 5 to the top and the bottom. We get 25/10 minus 9/10. Now, is 25/10 the same thing as 5 halves? You could reduce it, right? So we didn't change the problem. We just looked at it in a different way. And the reason we looked at it in a different way is so we could see that, look, now we can combine these. 25 minus 9, 16. Which means b equals 8/5. So we cross at 8/5, almost 2. And our equation is y equals 9/5 x plus 8/5. I'll see you guys next time. Don't worry about this for homework. Your parents are like, why isn't he giving you more homework? Be like, cuz. I don't know. That's all I got.
Why not?
Good news, bad news. These are harder than the ones you'll have to do for the quiz on Friday.
Hey.
And there will be a quiz on Friday, which is the bad news. Most of it will be over vectors and translation, though.
Right?
So that should be easy.
I just want to go over this now.
No, we're going to do some more on it. We're going to do more on this stuff, but it's not going to just be this worksheet. You're going to be gone tomorrow? Okay.